from the homework 7.5, hypothesis testing for variance and standard deviation. This is going to be question 19. So an insurance agent says the standard deviation for the total hospital charges for patients involved in a crash in which a vehicle struck a construction barricade is less than $3,300. A random sample of 20 total hospital charges for patients involved in this type of crash has a standard deviation of $3,800 at a level of significance of 0.01 or 1%. Can you support the agent's claim? And we want to use the p-value method to test the claim. So the p-value method is the strategy they want. And so we'll see if we can walk you through this strategy here. The first thing, of course, is just identifying what the claim is and also the alternative, the null hypothesis and alternative hypothesis. So let me move over to my Word document. Let's see if I can bring this all up here. So this should be the same question. So what I pick up on to start with is, let's see if I can get this thing right. So at the very beginning here, we kind of pick up on that the standard deviation of the total hospital charges for patients involved in a crash is less than $3,300. That's our claim. So since that's a less than, that's going to be our, when I look at my null hypothesis and my alternative hypothesis, since this is an inequality, the standard deviation is less than 3,300. That's going to go down for my alternative hypothesis. And the equality always goes for the null hypothesis. So the standard deviation is going to be greater than or equal to $33,300 is going to be the null. So remember, the claim is down here, though. This is what they're saying. So from there, we kind of pick up in our, on the assignment that the null hypothesis and the alternative hypothesis, we're looking for that less than 3,300. That looks like this A. So if I check that answer, we got that going. So next thing they're asking for is identifying the standardized test statistic. So since we're doing hypothesis testing for variance and standard deviation, this involves then our chi-squared strategy. So to find our test statistic, we're looking for chi-squared. And remember, the formula is the degrees of freedom, which is n-1, times the sample variance, which is s squared, divided by the population variance, which is sigma squared. So to find chi-squared, if you will, since the sample is 20, we know the degrees of freedom is actually 19. When they did the sample of 20, notice that they came up with a standard deviation of 3,800. So if we square that, that's going to give us our sample variance. And then if we divide that by, again, the standard deviation of the population, if you will, was that 3,300. So the 3,300, if we square that, that's going to be our population variance. So using our calculator, we can find our standardized test statistic. So I'm going to use the alpha key and just put it in as I see it there, kind of use fraction. So 19 times then this 3,800, and we'll square that, and then divide it by the 3,300, and we'll square that. And then we'll change it to a fraction. So math, answer to fractions number 2. So that's the sample test statistic we're going to use chi-squared to represent that. And if we round to 2 decimal places, we're going to have 25.19. That 3 would tell us to bring it on down. So 25.19. So notice how it does say round to 2 decimal places. So if we type in 25.19 there, that should give us our standardized test statistic. So next thing it wants to do is identify this p-value, and it wants us to round it to 3 decimal places. Now, the thing about the p-value is this. If we go up here a little bit, I have some notes. When I'm making a decision to reject or fail to reject a null hypothesis, if the p-value is less than or equal to the level of significance, then we reject h of 0. Otherwise, we fail to reject h of 0. So this is compared always to the null hypothesis. So we will make a note that if p is less than or equal to alpha, we're going to reject h of 0. If p is greater than alpha, we're going to fail to reject h of 0. Okay. So that's the level of significance here. So again, if we look at that, again, if the p-value is less than or equal to alpha, we're going to reject h of 0. Okay. So in our problem right here, the level of significance was 0.01. So keep getting too many stray marks here. So if the p-value is less than or equal to 0.01, we're going to reject h of 0. And if the p-value is greater than 0.01, we're going to fail to reject h of 0. So to do this, what we have is, if I look at this drawing, if I draw the chi-square distribution, kind of looks something like that. Notice how we are less than 3,300. Remember, this always comes from the alternative hypothesis. So this less than tells me that this is a left tail. So the chi-squared part, this 25.19, is going to be here. And what we want to do is find the area of the curve over here. That's going to be our p-value. So to find the p-value, we're trying to find the area of the curve. So to do this, let me find my calculator. We can actually use a chi-square distribution. So using technology, we can use this chi-squared distribution. And since we're looking for the area of the curve, this is that cumulative, so CDF, if you will. So if we go to distribution, which is above ours, if you look at number 8, notice how it's got chi-squared CDF. So if we go down to number 8 here, this gives us the area of the curve. So notice how, since this is left-tailed, there is no left bound, so we use a negative 10,000 there. There is an upper bound, which is just 25.19. And the degrees of freedom, notice how we had a sample size of 20 up here. The degrees of freedom was 19. So if we put a 19 in there, this will actually determine the area of the curve, which is actually going to be our p-value. So if we round that to 3 decimal places, we're going to get 0.845 or 846. So it's going to be 0.846. So we're kind of picking up on 0.846 as our test statistic. I'm sorry, as our p-value. So p is going to equal approximately 0.846. So if I go to my homework, if we type in 0.846, that should give us the answer there to that. So now the question is, what do we do with that? So remember, if we are less than or equal to 0.01, we're going to reject h of 0. But if we're greater than 0.01, we're going to fail to reject h of 0. So if I put this 0.846 in, how's that going to compare to 0.01 if I go at an extra 0 point? So it's going to be like 0.010, and this is going to be 0.846. So 846 is much bigger than 10. So this is going to be greater than. So this tells me that we're going to fail to reject h of 0. So if we fail to reject h of 0, again, and notice that our claim is actually the alternative hypothesis. So if we go back up to our interpretation, if we fail to reject h of 0 and our claim is the alternative hypothesis, there's not enough evidence to support the claim. So we have that kind of going on, the support concept. There's not enough evidence to support the claim. So if I go to my question, since it's greater than 0, we're going to fail to reject h of 0. And there's not enough evidence at 1% to support the agent's claim. So we're kind of picking up on that one, since the claim was actually the alternative hypothesis. So we can't support the null hypothesis. There's not evidence to support that. So there's not enough evidence to support the agent's claim. So again, if we use that little table, you can kind of pick up on that. We check our answer there, that should check out for us. So that's kind of how we can do this using the p-value, is we actually can use the, we can actually find the area of the curve using this K distribution, chi distribution CDF on your calculator. And then we can compare that to the level of significance in the problem.